Hello. People will start filing in. Just as you all file in, you may have noticed we're missing the dulcet tones of Guy Coward, who's normally your MC. You've got me tonight, Chantal Hale. I'm with IT Masters and I help to deliver our Masters courses. Welcome to the fourth and final webinar for the Knowledge Discovery and Data Mining short course. And tonight, as we had last week, we have Michael Bewong with us, who will be delivering this last webinar for us. We encourage the asking of questions and chat during the webinar. So there's two methods you can do that. It's obviously the Zoom webinar chat, and that's so that you can chat with your fellow attendees. So remember to change your to field to all panelists and attendees so that you can really interact with the other students. And then of course there's the Q&A section, and that's where you put any questions that you want Michael to answer later on or when he gets to the end of that area, and we'll make sure that we have a few designated times in which to answer questions in the Q&A section. Also tonight we've got Jason Howarth from CSU. He will talk a little bit about the graduate certificate that this is based on at the end of the course. So if you have any questions about that, or if you want to know a little bit more, stick around for that. Okay, Michael, I might hand over to you and we can start on this final webinar.
Thank you very much, Chantal. I hope you can all hear me all right. All right, so welcome again to the MOOC lecture series. Today we'll be talking about decision support systems. Just to give a bit of context of what we're going to be doing today, I'll just recap some of the things that we've done over the last 4 weeks. So in session one, we started off. Can you all hear me all right? Just checking. Chantal, can you hear me?
Yeah, I can hear you fine. And it seems like all the students can.
Excellent, thank you. So just to recap the stuff that we did, in session one, we pretty much looked at the introduction to data mining. So the emphasis there was really what data mining is. And we saw that it is really using a suite of tools to discover knowledge from data to solve real-world relevant problems. So 3 main things that we saw from there: the what, the how, and then the why. So the what involves the tools that we use. The how involves how we combine these tools to discover knowledge. And then the why is why we actually combine the tools in the way that we do and why the results are presented the way that they are. So as I mentioned last week, the why is really the most important part of data mining. In session one as well, we looked at the introduction to the data mining lifecycle, basically looking at data collection all the way to knowledge reintegration. In session two, we focused on decision tree classifiers. So decision tree classifiers is one of the many machine learning tools that exist. In decision tree classifiers, there are 2 main things that we needed to understand there. So the first thing is how to build decision trees. And generally, the algorithm for building decision trees are referred to as decision tree induction algorithms. The second thing is how we use decision trees to make predictions. In session 3, last week, we focused on knowledge discovery, all right? So knowledge discovery focuses on how we make sense of models and what relevant information we can extract from the model. So pretty much talking about interpretability. There we looked at 3 main things. So the purpose, which was really to define an objective for the data mining task, knowing the tools to use, and then discovering the knowledge. The second thing we looked at there was the techniques that were used. So we saw that broadly we can classify the techniques into supervised and unsupervised learning algorithms. Generally, when we say supervised, it means that the data set that we're using are labeled. And when we say unsupervised, the data set that we are using is not labeled. And then finally, we looked at interestingness measures. So we realized that we can discover a lot of rules, so knowledge in the form of rules or patterns. However, of all these that we discover, which ones are most interesting? So there we looked at interestingness measures. So some of the measures that we looked at work, support, confidence, conciseness, actionability, and so on and so forth. And then we looked at how all of this worked out in a case study. So having recapped all of that, this week we are looking at decision support systems. So decision support systems allows us to actually incorporate all the knowledge that we have discovered into a functioning system. So the aim of this lecture really may not necessarily be to show you how to build a decision support system from scratch, but it's to enable us to understand what it is and what is involved in it. So the skills required to build a decision support system is out of the scope of this subject. However, there are other subjects within the grad set and subsequently the masters that will give us the tools that allows us to build right away from simple dashboards all the way to full functioning systems. So the reason we're looking at this topic today is that as a data miner, once you build your models, you need to present the information in some sense, all right? So presenting the information in some sense often would end up to be used for decision making. And that is why we need to understand decision support systems. So that, for example, once you have your prototype and then we have a software engineer who is actually converting that prototype into an application or a software, you as the data miner, you have an idea of what goes into the building of that software. All right, so going on to the outline for today's lecture. So there are three main things I would like to cover. In the introduction, I'd like to look at the types of decisions that we make, the types of decision problems, types of decision support systems, and then from there, we'll look at the architecture of decision support systems. In looking at the architecture, we'll look at a case study and then reflect the components of the architecture within the case study. And then finally, we'll look at the requirements of a decision support system. At this point, is there any question at all on what we have done previously and what we are going to do?
There's nothing in the Q&A. I'm not sure
Excellent.
if just typing them in, but I think we can
go on. Excellent. Sounds good. Sounds good. All right. So first of all, we may say that a decision support system is any system that aids users in decision-making process. And when we talk about a system, we are really talking about a group of interrelated software that is working towards an objective, okay? So this interrelated software could be a user interface, it could be a database management system, or it could be actually the data mining models that we have developed. So generally, when we talk of decision support systems, we're really trying to support decision makers rather than replacing them. Now, when you go on from decision support systems where we do not have a human in the loop, then we are talking about autonomous systems, all right? So autonomous systems are really systems that do not have a human within the loop. Beyond that, we can talk about technological singularity, where computer systems are self-sustainable, they become curious, they are self-aware, self-improve. And actually that is where we become extinct. But experts say we are far from that, right? Now, decision support systems can really help us make decisions. It could be simple decisions as to, for example, what movie we should watch, to decisions that has an impact, like which crew members should we use for a particular flight, okay? So in technical terms, when we talk about the first problem about what movie you should watch, we generally refer to this as recommendation problem. In data mining, some of the solutions to this are generally referred to as recommendation systems, and they rely on two main characteristics, or two main types. So the first type is what we call collaborative filtering. So collaborative filtering simply means that we use the user's previous history as well as other users that are similar to this particular user. So for example, John Smith is 45 years old, he plays soccer, he likes to drink beer on Saturdays and watch military style movies, all right? If there's another individual, let's call that individual Peter Smith. Peter Smith is also 46 years old. He likes to play soccer and he also likes to watch movies. So the question would be, what types of movies would Peter Smith like to watch? Because Peter Smith and John Smith have similar characteristics on all other attributes, we may use John Smith's movie types to recommend a movie for Peter Smith. So in this sense, we call it collaborative filtering, because we're using knowledge from personas that are similar to the persona that we want to recommend to. The second one is content-based filtering, where we actually use tags within the content to actually recommend movies. So at this point, what I'm talking about are the tools that we are using, the data mining tools that we are using. The aim of this topic that we're discussing is how those tools are used to support decisions. So in this case, a decision like you want to watch a movie. When we talk about more serious cases like crew members, we generally refer to that problem as a scheduling problem. Now, this belongs to the broad group of problems, which we call optimization problems, which has various constraints. And generally, we try to optimize an objective. So in this case, the objective might be the cost, all right? So in that sense, let us look at the types of decisions that we tend to make, or these systems will tend to make. So two types. So the first one is a simple view, where we want to make a choice among an alternative. So whether an individual will have cancer or not. The second type is a complete view, where we want to look at the choice options. So in the complete view, we are looking at how each of the attributes affect the outcome. So for example, in last week, I introduced this data set to you. So this data set is about individuals and their diagnosis. And in this case, the diagnosis being cancer or not cancer. Now, when we talk about simple view, then the decision could simply be, will John Smith get cancer if he smokes tobacco? That's a yes or no. So a choice among these options. However, a complete view would be which combinations of attributes would affect his outcome. So in this case, if we are looking at the outcome being the diagnosis cancer, then we can say, well, one choice option would be 50% reduction in tobacco, 50% reduction in alcohol, 10% increase in exercise will result in 70% reduction outcome. Now, another option may also similarly result in 70% reduction in outcome. So at the end of the day, we have options, and the user or the decision maker can choose the option that best suits. So in this case, John Smith might say, well, I'm not a fan of exercise, but so I'll go with the second option because it has the same outcome as the first. So these are the types of decisions that generally we require decision support systems to help us to make. Then we may look at how the types of the decision problems are structured. So generally we have two main types, the structured and unstructured. And of course, we can talk about the semi-structured, which lies in the spectrum between structured and unstructured. So when we talk about structured problems, we're generally talking about problems that are well-known, problems whose solutions are defined. So we can talk about manufacturing process, or for example, the making of alloys. We can say, well, if you have aluminium, you add scandium to it, you get a metal that is good for aircraft. Add magnesium and chromium, you get a metal that's good for ship. Add magnesium and silicon, you get a material that is good for bicycles, and so on and so forth. So these will never change, all right? So these are fixed. We can also talk about a production line of beverages, right? So in that sense, you may say that if the bottle is between 70 and 90% full, we accept it as good quality. If it is above or below any of these thresholds, we reject it. So this also does not change. So in this sense, we say that the problem is structured and the solution is well defined. Generally, when we talk about decision support systems, we are talking about unstructured problems and semi-structured problems. So unstructured problems, generally the problems are not known. So for example, what is the likelihood of someone buying a bicycle given his profile? Okay, so this problem is not necessarily structured. And to solve these, we may use tools like data mining tools to train models and use those models to help us to make a decision on this. In such problems, we generally try to approximate a structured version of the problem and then use a solution for the structured version of the problem as a solution for the unstructured. So that is where it is a decision support system, because the human in the loop takes care of that unstructured nature within the approximation. All right, now, so in that sense, we may say, well, what are the types of decision support systems that solves these types of problems? Now, I must note that the primary difference between decision support systems and other information systems, such as database management systems, is the presence of a model to support a solution. So when we talk about the types of decision support systems, we may talk about two main types: the model-oriented decision support systems or the data-oriented decision support systems. In the model-oriented decision support systems, generally we are looking for, we assume that the model exists prior to the decision-making activity. So generally, these models will rely on simulation tools to search through a set of feasible solutions to get you an, so to say, optimal solution. Now, so for example, if we say, what are the options of making bicycles from 6 kilograms of aluminum sheet? Well, there could be two options: 2 bicycles in 3 hours because the machine has to cut carefully, or 1 bicycle in 30 minutes because the machine does not care how to cut the material. So in that sense, the decision maker can take this information and then make a decision. In this sense, we are not relying on data to train a model. But in data-oriented decision support systems, we generally rely on data to train models and then use those models to make our predictions. So for example, if a customer buys a bicycle, what else would he or she buy? In that sense, we need to use historical data and then train a model to determine the association between bicycles and other items. Now, we may also look at other types of classifications like document-driven decision support systems, which focuses on unstructured data, particularly text data, or knowledge-driven, which focuses on rules obtained from experts. So for example, if you have a diagnosis application meant for a rural area, the decisions that are made might have been sorted from a medical expert that says, well, if your skin is pale and you're bloodshot, then you're probably suffering from fever or something, right? So in that sense, we say that it is knowledge driven because the system is built on rules. The third other classification is communication driven, where it really focuses on collaborative settings. So in this regard, I have a couple of colleagues who work in the augmented reality area, where one of the research problems they try to solve is if you have 2 people geographically separated, and say, for example, one is a mechanic and the other is not, and there's a problem on a vehicle, then is there a way that the person who is not the mechanic can actually make decisions through the help of the other person by augmenting the reality, in this case, the vehicle, so that the mechanic can actually place tags and make points so that the lay person can actually fix the problem. So these kind of decision support systems, we say they are communication driven because they are using communications to aid in the decision making. Now, in this subject, we really focus on data oriented because we are looking at how we use data mining techniques to discover knowledge from data and subsequently use that knowledge to make a decision. So At this point, I'll probably pause and ask if there are any questions at all on what we've looked at in terms of the types of decisions, types of decision problems, and then the types of decision support systems.
So we've got two right now. Just a quick one asking what ML means, which was one of the acronyms on the page before.
Oh, sorry about it. So that means machine learning.
Machine learning, great.
Yeah.
And then do unstructured problems become structured problems given enough data and history?
No. So an unstructured problem means that there is uncertainty that we cannot model. So generally, when we train computers to make decisions, computers can only make decisions if there's a structure. So for example, if we talk about a decision tree classifier, to make predictions as to someone will have cancer or not, what we are essentially doing is that we are taking that complex problem about someone having cancer and simplifying it into a decision tree and saying, well, if you satisfy these criteria, then you're probably not going to get cancer. So that tree in itself is a structure, and it is structured, and it is solving an unstructured problem. And so that is why you probably not get 100% accuracy on your tools or machine learning tools all the time. So hopefully that answers that question.
And then we just got one other question. How did you get 2 different times for bike manufacturer from kilos of aluminium 2 hours, 2 over 3 hours,
Yeah.
1 over 30 minutes?
That was just an example. So I was just trying to illustrate the fact that if you have a machine making tool, and then that machine is to make a bicycle from a single piece of aluminium, then of course you don't care how you cut the pieces of aluminium to make the bicycle. But if you need to make 2 bicycles, then you probably need to cut them carefully so that you can optimize the space on the aluminium sheet. And so I was just using that to illustrate the fact that for a different outcome, you might require a different length of time. So here, my emphasis was on time and cost. So if you're a decision maker of a factory that makes bicycle, then, well, you need to decide whether you're going to emphasize on time or on cost. So in this case, I was just trying to use that to illustrate that point. So I don't make bicycles, I just, hopefully that answers that question.
Yep,
all right.
So that's it for questions so far.
All right, okay, so we'll carry on. So now we'll look at the architecture of decision support systems. Now, what I'll do in looking at the architecture of decision support systems is that I'll present a case study, and then we'll look at the components that make up the architecture and then link those components back to this case study and see how it reflects in reality. So this case study, this was a project that was done by Zahid in 2016. So it was pretty much a proof of concept decision support system that was aimed at predicting things like volume, inflow, evaporation, and release rates from dam. So obviously we know that this is an important problem, especially in this era of drought. So being able to predict these variables, of course, can allow farmers to make preparations. It can allow policymakers to put the right policies in place and make timely interventions. So I cannot overemphasize the importance of such a problem and such a solution. So to make such a decision support system, the general architecture has 4 main components. So we may talk about the dialog primitives, which is nothing, it's just a fancy name for user interface. We may talk about the database management, we may talk about the model management, and then we may talk about the solution-based management. Now, when we talk about the user interface actually is the main point of contact between the decision maker and the whole system. So arguably, it might be the most important part of the system. So because of that, we need to ensure that it satisfies certain characteristics. So for example, it needs to satisfy support for model choice. So the user needs to be able to decide which model he or she is going to use. for solving the problem. Of course, you can define default models, but ultimately, it is useful to allow the user to be able to decide which models to use for a particular problem, because the user may use background knowledge, may use experience, may use some knowledge that is not available to the decision support system. So for example, if you have a data set and that data set, let's say the class variable is numerical, then the decision support system may use regression analysis because it sees the data type to be numerical. However, to the user, that might be considered categorical, or the user might want to do categorical analysis on the class variable. So in that case, the user needs to be able to modify the model that is used. Secondly, we need to be able to support the reasoning. So if we say, for example, these three products in the shop are always going to be purchased together, and therefore when we stock items, we need to stock them always together. We need to provide justification for that. And that justification could be for some of the interestingness measures that we saw last week. So it could be things like the support or the confidence. Now, just drawing from my experience on some of the projects that I've worked on in the past, I worked on a project where we tried to predict civil unrest events, okay? And there were one major aim was to ensure that the accuracies of our predictions were good. So we wanted to say, okay, there's a 90% chance that there will be a civil unrest event, maybe in Sydney, for example. But that information is okay. Well, 90% chance there's going to be a protest in Sydney. Where is it going to be? What is it going to be about? All right. So what we needed to do in the decision support system was that we needed to provide context to the predictions that we're making, to support the predictions that we're making. So for example, to say there's a 90% chance that there's gonna be a protest in Sydney because of climate change rallies, okay? Or because Milo Yiannopoulos is giving a speech, or because there are vote yes and no rallies. So this gives better context to the decision maker to decide whether or not they are going to deploy police to keep peace, and that can even tell the type of intervention for the decision maker to make. So it's really important to provide support for the choices that the decision support systems are made. Now, generally, when you build a model, a data mining model, you generally would be doing predictions, but you can also build data mining models that provide context to the predictions that you are making. The third point is that you need to be able to provide support for choice and optimization of the variables. So what this means is that we need to be able to allow the user to tune the parameters of the variables. And last week, somebody asked me a question about what is the best confidence value to use. Now, if you're a decision maker, this is where you can vary those parameters, like the threshold for the confidence values. So for example, you might say, well, your default value might be 50%. And as a decision maker, you might say, well, I want to look at the rules or the knowledge that is discovered when the confidence is 90% and act on those rules only. And so you need to have the ability to be able to modify those decision variables. And finally, we can talk about the graphical interface. So the graphical interface obviously is very important because that gives a holistic overview of the solution and the problem in such a way that it's not too cumbersome for the decision maker. So graphical interface is always very useful in decision support systems. Now, reflecting these characteristics of a user interface in the case study, we may look at the Water DM decision support system. So this was developed, as I mentioned, by Zahid in 2016. Now, this is a clean interface that allows you to do some visualization. It allows you to determine what models to use for the knowledge discovery. I think the prototype allowed for decision trees, but obviously when you develop such tools, you have multiple models that the user can choose from. That allows you to make predictions, of which is what we obviously want to make, to track the prediction accuracy and so on and so forth. So generally, I mentioned with the user interface, you want to be able to allow the user to actually interact with the underlying models in such a way that is flexible. So then we can also talk about, after looking at the user interface, we may talk about the database. Obviously, we need data to build the models, and therefore the database is an intrinsic part of the decision support systems. Now, sometimes the user might just want to query statistics about the data. So, so it is important to have the database to be able to interact back and front with the user interface. We can also talk about the model base. So the model base or model management, that is where all our models are stored and managed. So if the user wants to make a prediction, that prediction will actually access the right model that is relevant to the problem. If the model does not exist, then there should be a system that triggers a new model to be trained and stored to be part of the model base. And we may also want to talk about a solution base where we store all previous predictions, because sometimes you may want to actually make a prediction on an item that already has a solution. So rather than actually training a new model or making a prediction on a new model, you may just call upon the solution. Or you may also want to track how your predictions are behaving. And so all of these put together make the decision support system. Now remember, a system is nothing but a group of interrelated software working together to achieve a common objective. So in this case, decision support. Now, so as I've mentioned, we'll look at how all these components are reflected in the case study for WaterDM. So for WaterDM, we see that the database is represented as data from the Bureau of Meteorology, New South Wales weather zone, and so on and so forth. Now, on the local server side, there's a scheduler. Here we call it a cron job. So that is nothing but a scheduler that actually collects data from these data sources periodically. And then that splits the data into whether it relates to raw water or it relates to weather. And then here we do the pre-processing. So this is one of the topics that we cover in the subjects as well, pre-processing. So when you have data, it might be dirty in the sense that there might be redundancies, there might be missing values, there might be duplications, and so on and so forth. So here we do the pre-processing to clean up the data. So all of this forms part of the database. And then once we have the clean data, we might train our models. So the models that we talked about, in particular, we talked about decision tree classifiers. So we might invoke the models to be trained on the data that we have. So here we can refer to this as the model base. Now note that the user is interacting with all of this through the user interface, which is nothing but a PHP website. Okay. And then obviously we have a database that stores the previous predictions and so on and so forth. And we may say this is the solution base. So here, at least we see how the various components of an archetypical decision support system is reflected in this case study of WaterDM. Okay. All right. Now, so now we'll probably move on to the requirements of a decision support system. Now, generally, when we talk about the requirements, we talk about two major things. We talk about simplicity and consistency. Now, when we say simplicity, we are saying that we want to organize the information in such a way that the human being can understand, or the decision maker can understand, or we want to take into consideration the cognitive capabilities of the decision maker. So, well, fun fact, normal human beings can handle, I think, 4 concurrent things at once. So, I mean, I can barely manage 2 concurrent things. So I'm not talking about super smart people, I'm talking about normal people. So if you bombard a decision maker with a lot of information, it's probably not going to make the decision making process any better. So we are not saying that you simplify the problem. We are saying that you simplify the presentation of the problem so that the underlying complexities are still there. So in this way, if the user wants to get more information about a particular component, the user can get it. So for example, when I talk about simplicity, this is what I mean. So these are 2 interfaces for investment. One is clean and you are able to dig deeper if you want, and the other presents all the information in one go. So if you probably design this sort of user interface, it might be the last user interface you design for any company. So you might want to take this into consideration. The second important thing is consistency. So when we talk about consistency, we may talk about 2 main things. So internal consistency and then the needs outcome consistency. When we talk about internal consistency, we're talking about data representation, how we handle data, and so on and so forth. So supposing you have models that are predicting probabilities. Now, it's either you decide to present probabilities for all the models to be in percentages or to be in fractional values. So if one model presents a probability as 90%, or in a percentage, then you do not want another model to present a probability in fractionally. So that is one thing you need to consider. When we talk about consistency, we're also talking about data consistency. So in one data set, you don't want to use last name, and then another data set you use surname. So that does not give internal consistency. Now, when we talk about needs outcome consistency, then we are saying that we want your outcome to match what the user is expecting. So if the user is expecting a yes or no answer, then you don't want to design a decision support system that gives probabilities, because that might not be useful to that user. Now, again, reflecting on some of the work that I've done in the past, still relating to the civil unrest predictions. So when we started the project, we used various metrics and then came up with one metric that we call the risk score. Now, whilst risk score was understandable to us because that really presented or reflected the risk of an event, it wasn't entirely understandable to the clients. In fact, the clients simply wanted categorizations. Okay, categorization like low, medium, and high risk. That's all the client wanted. So in that sense, we had to convert these risk scores into those categorizations. And to do that, we needed to convert them into probabilities first. And converting probabilities into categorizations is not that straightforward. Well, you might say, well, anything above 70 is high, anything between 50 and 70 is medium, and anything below 50 is low. But generally, those problems are not that easy to solve in that sense. In this case, not only did we have to consider the probability of an event occurring, we had to consider the scale of the event. Okay, so for example, if you predict that there's going to be 90% chance that there will be civil unrest and only 1% turns up, well, it's not worth for the decision maker to send police to go and check that person, right? But if you can combine the probability that it's going to be 90% that this is going to occur, and you're going to have about 1,000 people turn up, then that is something that we need to consider. So we needed to consider all of this information to classify or to categorize events as low, medium, or high risk. And if you've done some data mining before, you know that this is not a very easy task to achieve in that sense. And then similarly, on another project, we actually, that was for us to predict exploits of vulnerability. So we started out by predicting yes or no. So basically whether a vulnerability will be exploited or not. But a client wanted probabilities. So two different clients, they both wanted different things. And so we had to design the system such that it conforms to what the client wanted. So when I talk about needs outcome consistency, it can really be summarized by this. All right. So if a client wants this, don't present the client with this. That's pretty much what it is. It might make sense to you, but in the end of the day, it is a decision maker who is actually going to make those decisions. So I think that brings us to the end of the three main things that I wanted to talk about in decision support systems. So basically, we looked at the types of decisions, types of decision problems, types of decision support systems. When we talk about the types of decisions, we look at simple view or complete view. When we talk about the decision problems, we are looking at structured or unstructured problems. When we talk about the support systems, then we are looking mainly at data-driven or model-driven. There are other ones like communication-driven, knowledge-driven, and so on and so forth. Then obviously we looked at the architecture of decision support system, which has four main components. So there we can talk about the user interface, which is arguably the most important part of the decision support system. We can talk about the model base, the database, and then the solution base. And of course, when we talk about requirements, we talk about the fact that the system must be simple. It doesn't mean that the underlying models must be simple. It just means that we present the problem and solution in a simple way. It must also be consistent. That means that what the user or the decision maker expects conforms to what we actually provide as a decision support. So I'll just summarize this topic by drawing my own experience. Now, again, talking about the predicting of civil unrest. So when we're working on this project, there were two main things that we were tasked to do. So to ensure that the accuracy of our predictions were high, and also to ensure that we provided justification or support for whatever predictions that we were doing. So as data miners, we predominantly focused on these two things. So one of the meetings we went to, we presented our results and we said, oh, well, we really have high precision recall and F1 score, and we're getting something like 0.8, 0.75. Now, in that presentation, the researchers that were sitting there were quite intrigued. They were like, oh, how did you do this? And we were going on and rambling on about the techniques that we were using. But the analysts that were to use the tool were not really fascinated by it, right? So in a subsequent meeting, what I did was that I converted all of that we're saying into a prototype. The prototype was nothing but an interactive graph that had spikes. So the spikes indicated the probabilities of an event occurring. And when you click on the spike, that gives you some supporting information about what the event is about, when it is going to occur, that sort of information. In the subsequent presentation, everyone was much more appreciative of the information that we had presented. Now, again, the same models, the same results, but just presented differently. So if there's anything for you to take home today, it is that decision support systems are really important. And it is the end game of the data mining process. So once you do all your data mining, you build these beautiful models that have high accuracies. It is only useful if we can embed them into a decision support system to help make decisions. So at this point, I'll ask if there are any questions at all about the lecture that I've given now.
Okay, so we've had a few questions, and some of them are probably less relevant than others, but we'll go through some of them.
Yep.
We had somebody asking about what a DM is in New South Wales, wondering what was in play in Queensland a few years ago when there was severe flooding, and Hamilton had some feedback on that. I just thought I would highlight that verbally, because check out the Q&A for that information. Hamilton asked about, I think, about the discussion about decision support systems. Could this be used for matching missing persons and deaths of unknown people? ABC Oz Story had this last night.
Yeah, no, absolutely. So in this case, it will depend on what data would be available to us. It could be data from traffic cameras. It could be data from schools or that sort of thing. But ultimately, anything that any data that is relevant to the problem can ultimately be used in a decision support system. So it will depend on the specifics of the problem, but yeah, most certainly. Actually, that reminds me of a project a colleague has been working on, and that is on entity resolution. So that research is trying to identify whether any two profiles are the same in a database. So sometimes you might have an individual in one database calling himself William, and then in another database calling himself Bill, right? And so then the question is, well, how do we know that these two people are the same? So there are some complex techniques in solving that sort of problem, like using graph dependencies and so on and so forth. So most certainly for the missing persons case, I would assume that we can model it as an entity resolution problem and then use some of these techniques to resolve it. But they are very complex techniques to use. Was there any other questions, Chantal?
Sorry about that, I was muted.
Yeah, all good.
Nora's asked, I still don't understand the difference between a data miner and a data scientist. All the steps mentioned so far are done by data scientists.
Okay, to be honest, the term data miner and data scientist are synonymous nowadays, all right? So there's, as far as I'm concerned, there's no real difference. So some people might call themselves data miners, some people might call themselves data scientists. The skill set that you require to do both are essentially the same, right? So I think it's a choice, a personal choice for people, really.
And then we've just got one last question so far. Is supervised learning another way of suggesting that a particular DSS has no programmed model related to the problem, but the machine is allowed to do some clustering, etc., to come to a conclusion?
Yeah, that's correct. That's actually well put. So when we talk about supervised learning, we do not have labels, and so the decision support system may try to discover some patterns. Now, these patterns could be clusters, it could be association rules, it could be anomalies, and so on and so forth. So that's exactly on point. Yeah, that's correct. So just wrapping up then, I'll say that over the last 4 weeks, we started by looking at an introduction to data mining. Then, of course, we went on to look at decision tree classifiers and how we can use that to, how we can build decision trees and how we can use that to make predictions. And then we went on to look at knowledge discovery from decision tree classifiers, basically the interestingness of knowledge that we can discover. And then finally, we have looked at decision support systems. Now, in the subject, we cover a few more topics like corrupt data detection. We look at privacy preserving data mining, clustering, time series data mining, and many more. Now, all these are tools or techniques that are relevant to solving various types of problems. So a tool like decision tree classifier may not be good for solving an unsupervised learning problem. In that case, you might want to use clustering. So I entreat you all to enroll in the graduate certificates if you can. And at this point, I'll probably hand over back to Chantel and Jason to give you a bit more details about how you can enroll into the grad set and hopefully in the future in the master's program.
Thank you so much for that. It was a really great lecture. I was obviously a little lost at times, but I hope everyone else could follow along. So as Michael said, this is part of a subject that's part of a graduate certificate in applied data science. And so we're going to hand over to Jason Howarth from CSU, who will talk to you a little bit about that course itself.
Thanks, Chantel, and welcome everyone. My name is Jason Howarth, and here to talk to you about the graduate certificate in applied data science. Thanks to Michael for a great presentation. Look, I've just copied into the chat window the URL. Perhaps don't go to it right now, but the URL of information about the full graduate certificate for those of you who are interested in moving on from this short course into a more formal program. So let me tell you what that's about, and also a little bit about Charles Sturt University, who you would be studying with. So not sure what you guys know about Charles Sturt. It is predominantly a regionally based university. So you can see there on the screen some of the photos from each of our different campuses. So we have campuses in large regional centres such as Albury, Wagga Wagga, Port Macquarie, Bathurst. But the thing many people don't know is that CSU, most of our students, in fact, are online students. So CSU has around about 40,000 students, 25,000 of those study online. So one of the largest universities in Australia for online learning. And what that means is you don't have to attend campus at all. You can do your degree wholly and solely online without ever setting foot on a campus. And for many people who are working, who have families, obviously that's an attractive proposition. So moving to the next slide, I just wanted to let you know that we are a leader in online education, and the kinds of presentations that you've seen by Michael, by Zahid in this short course, these are standard features of CSU online programs. Okay, so for those interested in doing what we call a graduate certificate, and I'll explain that a little more in a moment. Effectively though, it's 4 subjects to get a postgraduate award. We have this graduate certificate in applied data science kicking off for the first time next year, 2020. So you would be the first lot of entrance into the program and the first lot of graduates, and being an early adopter in areas that are very employable is often a really good strategy. So let me just briefly tell you about the program. First of all, it has what you can see up the top there, 1 core subject. And a core subject is a subject that every student of the course has to do. So that one here is Foundations of Big Data Analytics, and that covers areas such as introducing you to the practical concepts behind analysing big data, extracting value from masses of data. So you'll be looking at techniques such as data mining, machine learning, and AI. Now that subject is core. The other 3 subjects you get to choose depending on where your interest lies. So you get to choose those from the list of restricted electives. So yeah, look, Robin's asked a question there about programming principles. It is about a programming language. It's based on Python. So it's up to you whether you do that subject. Look, programming, whether you have that programming knowledge or not, but you know, programming as a skill is useful in so many different areas, including areas of data analysis that it would be a good choice. So that's based on Python. Just going through a couple of these, data mining and visualization for business intelligence. You're looking at basically the application of visual data sets. So how to present views of complex data trends and patterns. So it's all about presenting those views to other people and also helping to interpret those to other users. So often data, needs that visual representation to make sense. Database systems is all about more traditional database designs. So you're looking at, your traditional SQL type queries, building tables, all of the aspects around data integrity within database systems. Programming principles we've discussed. Internet of Things is fairly self-explanatory. There's a couple of statistical subjects where for those wanting to go into that side of data science are available to you. So we have scientific data analysis, and that one is, well, you're looking at things such as correlation. There is an introduction to R. Someone asked about that in the chat box. There is an introduction to R programming in that subject. Data classification and descriptive statistics, you're looking at probability, all those fun things. So that is an extremely useful subject. The other statistical subject there is experimental design and analysis. And that's really all about being able to have the knowledge to design experiments, but also to perform the analysis using the appropriate statistical protocols on those experiments. So you're looking at things such as linear regression, multiple comparison methods, analysis of variance and covariance, even an introduction to survey methods. So being able to get the data, but also to be able to create experiments on a small amount of data and to validate those. The last subject there that we haven't mentioned, ITC 573, data and knowledge engineering, is all about interpreting data using an ensemble of trees and clustering, also looking at cleaning data. So all the pre-processing tasks that you would need to perform before going on to do some real heavy number crunching. Also looking at the preservation of privacy there in that subject. Power BI, look, I'd have to check on that. I don't believe so. I don't believe so. So look, that's an overview. If you go to the link that I've pasted into the chat window, you can actually click on these subject numbers, and I'll show you that in a minute towards the end of the presentation. But that's an overview. It's only 4 subjects, not 6. Okay, you want me to paste again? Okay, there we go. Chantel, if we could just move the slides along. And I'm sorry for not showing my face tonight. I'm not shy, but I'm just traveling tonight, so the internet is a bit dodgy, so I don't want to use the video. So in terms of how long it will take, we'll get to that in a moment. In terms of the environment where you do your subjects, this is a screen dump of what's called a learning management system. So every subject that you enroll in, all of the 4 subjects in the grad cert, you would get access to this learning management environment where you obviously meet the lecturer, you go through each of your topics one by one. There's your assessments in there that you have to complete. You're able to chat to other students. You're able to obviously get not just written information about the topics, but videos, podcasts. It depends on how the lecturer designs their particular site. It's your one-stop shop. You can also submit your assessments through each of these portals. So everything can be transacted online. Okay, so thanks for that. Someone's corrected me there and pasted it to all the attendees. So what are the entry requirements? Just quickly, bachelor's degree or higher, you're pretty much straight in. But if you don't have a bachelor's degree, but you do have industry experience, there's a possible, we can possibly allow you in as well. It's a bit hard perhaps to verbalise exactly the industry experience that will get you in, but certainly if you've been working as a programmer in network engineering, in security, even in those different areas as a professional for 3 or more years, it's very possible that we would allow you into the graduate certificate. We'd need to look at, you know, the position you're holding. You know, we don't particularly want very junior level positions, but if you've been working in the industry 3 or 4 years, it's certainly worth putting in an admission, even if you don't have a bachelor's degree. One of the good things about this as well is that it's a pathway, whether or not you want to do that, into a master's program. Now, that could be with CSU, it could be with some other institution, but if you have a 4-subject graduate certificate, typically you will get straight into a master's, and you will get, depending on the program, of course, all of the subjects as credit. That would certainly be the case at CSU, where you would be eligible for credit and entry into our Masters of Information Technology based on what you've done in the grad cert. Yes, Robin, that would be sufficient, most certainly. Pardon me. Now, a lot of people don't necessarily know what a graduate certificate is, where it sits in the overall qualification hierarchy. At the bottom, and when I say at the bottom, these are university level awards, right? So it's still pretty high. At the bottom, you have your undergraduate degree, so your bachelor programs. Then you move up to your graduate certificates and graduate diplomas. They're postgraduate programs. They sit just below the masters. So they're high awards. They're higher than bachelors. They're only short, and they do allow you, as I said, to go into certain master's programs and gain credit. At the very top of the tree, typically more for researchers or people wanting to work in academic positions, are your doctorates. But I guess if you're doing research in industry as well, doctorates can be useful. And once again, you know, starting out with a grad cert, it may seem a long way away, but there is certainly a pathway to a doctorate from a grad cert through masters. So that's the qualifications and where they sit. So moving along, time commitment. How long, in terms of how long does it take you to complete, but also how much effort do you need? Our subjects are designed for you to do well if you engage with them around about 10 hours a week, 10 to 12 hours a week. That will vary depending on the subject and any exposure you have, how new you are to study. But on average, around about 10 hours a week per subject. Now, a session lasts around about 3 months. So it would be 10 hours per week over that 12-week period is what you're looking at for one subject, although you can enroll in 2. So you could do 20 hours a week and finish half your graduate certificate in around about that 3-month time period. So overall, the graduate certificate will take you, if you do it at 2 subjects at a time, and that's fine. 2 subjects part-time is a recommended load. You would finish in 6 months. So you can have variable study loads. You can just do 1, you can do 2, you can do more if you're feeling particularly courageous. You can take leaves of absence. So maybe you start in 1 session and just do a subject, and then you feel next session, look, I've got really busy at work, I need to have a break. You can just put things on hold and come back to it when you're ready. So there is that inbuilt flexibility. So just moving along now to credit. Some people will ask about credit. Credit may be available for any previous postgraduate study that you've done, but it needs to match, obviously. It needs to match sufficiently the curriculum that we're dealing with. So if you've done, for example, a master's in statistics, then it's very possible you could get a credit for one of those statistical subjects that I showed you. Industry certification, not so much in this course. If you did have an industry certification in some kind of data mining area, we could look at that for a possible credit, but it would be on an as-needs basis. We would have to look at that to see whether you would qualify. We don't give credit for work experience. Work experience allows you, for example, to get into the program if you're working in the industry, but there's no credit available for that. Credit is assessed as part of the application process. So when you apply, if you apply, you would upload any documents around that, and we would look at those as part of the application process on both whether you're admitted and also whether you could receive any credit. So just moving on to cost, important consideration. 4 subjects, you can do the maths yourself, 4 subjects in the degree. For Australian and New Zealand residents, $3,350 per subject. For international students, $3,550 per subject. There's also a small student services and amenities fee. I don't have the exact number, around about $30 a subject. You can certainly look at talking to your accountant about perhaps claiming this as a professional development expense if it's related to your work in some way. There's also government fee help programs where you can defer those costs. So there are different payment options. I won't go through them here. If you look at the website that I've posted the link into the chat window, you can find out some more information around that. HECS, Sadi, is different. That's around Commonwealth supported courses. Fee help is help. So fee help is what we're talking about here, not HECS. In terms of applying, we have a number of intakes next year. 2020 is when we kick off. So there are sessions starting in March, May, July, September, November. So lots of different options for you to start. You can apply now for the March intake. And really it's just up to you as to when best suits you if you're choosing to start, when that start time would be. It costs nothing to apply. Now I've got the URL there, csu.edu.au/apply. I'll need to check that, whether that's still current. We can check that in a moment. Let me just have a look there and see if that still works. The other one that I've got, and I'm going to paste it into the chat window, so all panelists and attendees, won't forget that one. Study.csu.edu.au. Are all subjects available through all intakes? No, they're not. Depending on when you start, yeah, you'll have different subject choices, Stannis. Now your core subject, ITC 575, from memory, that should be available into all the sessions. You'll certainly have a choice available. So you won't be constrained for choice, but not necessarily everything runs in every session. So let's just move along, Chantel. Look, if you do want any more information, and I'll actually start sharing my screen in a second, just take you through the very start of the application process. You can contact the course director. His name is Sabi Riemann. So SA Riemann at csu.edu.au. You can also contact me, Jason Howarth, jhowarth@csu.edu.au. Always happy to talk to prospective students. So if it's something you want to have a further discussion about, just please get in touch. Always happy to chat. And yeah, I mean, give it some consideration. I mean, obviously study is a big commitment and it's something that you don't do lightly. But, you know, it is a new award for us in a university that specialises in online education with a great reputation and in fact the leader in these types of courses in Australia in postgraduate IT programs. So let me just try and share my screen. Doug, no, you don't need to take ITC 575 first. It's not necessarily a prerequisite. Okay, so can you guys see what I'm sharing now? Chantel, can you just give me a verbal?
I can see what you're sharing. Yes.
Great. Okay, because I'm on a laptop and it got hidden. So if you go to study.csu.edu.au, start your application. It's just a matter of answering a few questions. There's an apply now button. You click on the apply now.
We might be losing audio a bit, unfortunately, with the addition of the video. How's everyone else's audio?
No? Okay, I can maybe just take you through with a few clicks rather than doing much talking. So I click on as a domestic student. It will ask me for the level of study and I would say postgraduate. And then it would ask me if I want to do teaching. For some reason, I really don't know why, we say no. And then it says, okay, go to the online application. Simple as clicking on that. And then you need to either register or log in. If you haven't registered before, I'm going to just log in here. And it will give you a few instructions around starting an online application, but we can just go down here to the start button and say domestic, and we would want postgraduate by coursework, graduate certificate, that's what we're after, domestic student, and we just, you can always come back to it later. And it's got all my details there, including my date of birth, which I'm not so willing to share because you'll know how old I am. But after that, you know, you go through your sections of education, which course, any documents to upload, and so on. So I'm just going to stop sharing there now. Oh, do I, Jason? Sound like an NBN customer. Sorry about that.
Thank you for that. And hopefully the Zoom recording should come through pretty smoothly on that one. If I was a guy, he would have come up with some clever joke about sharing your data and data mining and blah, 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 but I couldn't come up with it quick enough. So we're rapidly nearing the end of tonight's webinar, which means the end of the short course. The exam should hopefully be up tomorrow, and we'll send you an email once it's up so that you can start filling it out and getting certificates. Thanks again to Zahid and Michael for each doing 2 weeks of a really engaging short course with a lot of really interesting things there, and for Jason for coming through and helping us out here, and obviously for Guy for doing a much better job of this emceeing thing than I can manage. If you have any last minute questions, I think now is the time for them, but we should be wrapping up right about now. I always think I should have some background music while people type in questions, conceivably. But we haven't lost too much time at the end of this. 15 minutes over for the last one when we're going through a new course is pretty exciting. And again, any questions can go on the forums, Jason's emails. I'll see if I can share those on the screen again. Oops. Find me Zoom again so I can share my screen. So Jason's email there. Hopefully that's what you're getting. And yeah, like I said, any questions, post them on the forum. And I hope you've enjoyed this and learnt a lot.
Thanks, Chantel. Thanks, everyone. Appreciate your time as well. And a big thanks to Michael and Zahid. From us at Charles Sturt as well, great job. And thanks to all the participants too.
Hopefully Michael will be seeing some of you in his subjects when they next run.
Absolutely. I look forward to meeting a lot of the participants. So yeah, it'll be exciting.
And as we said before, this is just 4 weeks of an entire subject that would have many more weeks. And as far as I know, Michael goes overtime a lot. So it would definitely cover a lot more material. Right. Thanks again, and I hope to see you all next time we have a short course. Bye all.
Thank you.